Okay, so now we're back. We developed a graph for sine. Now what about cosine? So again, I'm being a little fast and loose with x and y, right? I'm now letting x be the input, but that's our old traditional theta or s. And cosine is basically the ratio that's created, or along the unit circle, right? It corresponds with, again, fast and loose, the x coordinate of any data point. So again, we're really making that transition almost maybe a little bit too fast. But again, along our x-axis, what's important to kind of do is look at the big 4. And if you want the big 6, right, 0, pi over 2, pi, 3 pi over 2, and 2 pi. So again, they correspond with all our quadrantal angle material. So let's see what's happening at the end of each quarter, and then we can fill in the details and look at what a sine graph does. So what we have again from the unit circle, we know that when x is 0, when I have an angle or an arc length of 0, right, the cosine value is 1. And then at pi over 2, the cosine value is 0. At pi, we've seen it being negative 1. At 3 pi over 2, it's back at 0. And then at 2 pi, it's back at being 1. So just plotting these big data points right there, right, the graph of cosine starts at 0, 1. At pi over 2, its output value is 0. At pi, its output is negative 1. At 3 pi over 2, it's back at 0. And at 2 pi, it's back at 1. So you already start seeing the shape of that graph. Like we did with sine, let's fill in a little bit more details. Let's go to the 45-degree angle. So that's kind of the halfway point between all those intervals. And so at pi over 4, we know that this is the square root of 2 over 2, which is roughly about 0.707. At 3 pi over 4, which is in quad 2, our value is negative, so it's negative square root of 2 over 2, so negative 0.7 over 7. And then we have 5 pi over 4, which puts us in quad number 3. That's also a negative square root of 2, or negative 0.707. And then we have 7 pi over 4, which would give us a positive square root of 2 over 2, because we're now in quad 2, and we're positive, which is about 0.707. So there's about 0.5. So at pi over 4, we're about 0.707. At 3 pi over 4, we're about negative 0.707. At 5 pi over 4, we're at negative 0.707. And at 7 pi over 4, we're roughly about 0.7. So if we connect our dots, right, what you're looking at is what the cosine graph looks like over one of its periods. And again, this is one full rotation, or what some people also call cycles. All right, so so there's that. And of course, if we would continue on, this curve, right, in any case, would continue to repeat itself. So again, this would be a period of 2 pi over here, although we're going in reverse, so negative 2 pi, right, would be right about there. And then somewhere down the line, right there would be 3 pi, where we come back in. But it keeps repeating itself because of the idea of coterminality. We're just going around this, and so the coterminal value of this would be the same as that. Now the coterminal value here, right, would be the same thing over here somewhere. So it just keeps repeating itself with that period, right, of 2 pi. So over one full rotation, cosine does whatever it's going to do, and that's basically that. Okay? And so let me kind of put these side by side so we can kind of compare. Let me move this a little bit. So now that we have our two graphs, so real messy, there's our sine graph. As a matter of fact, how about I just redraw that so it's kind of nice. So the sine graph we found over the same period, all right, let me try to get both of them on the thing here. So there's cosine, and here's sine, and so this started at 0, reached a high point, 0, reached a low point here. So there was our sine graph over the same period, or one full rotation. And you can see that there's some there's obviously some differences. There's different functions, but there's a lot of similarities. And you can see a lot of what we've learned about in our course thus far. Let me try to get that all together. Okay. First of all, what you see is what we've learned earlier, that the domain is actually everything. right? We can go forever and ever, both positive or negatively along the x-axis, and we're just going to keep generating this cosine wave, where in this case, we're just going to keep generating this sine wave. So the domain is everything, and we actually talked about that a few chapters ago. What about the range? Well, we can visually see that the range is from -1 to 1. The lowest value that a cosine graph is at -1, that occurs at pi, and the highest is at 0 and at the end of the rotation at 2 pi. Same thing for sine. It's at its lowest at 3 pi over 2, -1, and that's at its highest, all right, at pi over 2, which is 1. And so it assumes every value between -1 and 1, which is something that we kind of inherently already knew about the graph. Okay. Another thing that you'll notice, and I'm kind of getting a little bit into remember the cofunction identities, where we know that sine of theta, I think, was like cosine of theta minus 90 back in the day, although I guess this is now pi over 2. You can actually kind of see this in the graph. We'll talk about this a little bit more in some detail, but you can actually see, right, if we took this graph and kind of shifted it over about pi over 2, right, this part here would end up here, and we would basically have the sine graph, or vice versa. If we took this and shifted it back pi over 2, this point would be here, this point would be here, and we basically have the cosine graph. So that's kind of what they're saying in that theme, is that cosine and sine are basically a pi over 2 translation away from each other. And I'm kind of getting into some meat and potatoes of 4.2, but you can kind of make the cofunction identity, what we learned about in the past, makes sense now. All right. Some other things to notice. One thing about the cosine graph, it is what we call an even function, and that's because it's a mirror image, or how about I say symmetric. Here's some college algebra talk with you, right? It's symmetric with the y-axis, right? So the picture here would have its mirror image on that other side. So flip it across the y-axis and we get the same picture. That's a classic case of an even function, and that even means more, right? Because if you go back to college algebra, that meant that the cosine of -x is basically equal to the cosine of x. So here's pi, and here's -pi, and you can see that their outputs are the same. So the cosine of -pi and the cosine of pi are the same value, and that holds true for any x. Okay. What we also see is that the sine graph is what we call an odd function. If you guys recall from your college algebra days, right, this means that it's symmetric with the origin, or basically that the sine of -x would be equal to the negative of sine of x. Or essentially what that means is if I have a point here, right, its opposite would be down there. So notice this is the point pi over 2 comma 1, and if we rotated 180 degrees, or if we did a double flip right through that origin, it's both x's and y's become negative, and that's basically what it's saying. The input's negative and the output's negative, right? So we can basically see that. So that's one thing, again, now that we have a college algebra graph, we can see some of the stuff that we've just been kind of, trying to make sense of with all those definitions. I can literally see it happening, which is why we want to do this in the first place. We want to make these things into a college algebra-like function. And so there you go. What you're going to hear me say a lot, right, is everything comes down to these big 4 values. Everything happens in 4s, right? Where's your high points? Where's your low points? Where's your intercepts? If we can figure out how to move those 5 points, we basically have everything else, because the rest of the graph has to do what those 5 points do. So if I stretch them out, if I compress them, if I do a banjo and stretch them out, compress them along the x-axis, if I shift them up, shift them down, shift them left, shift them right, these 5 points have to go. Same thing here, right? All your intercepts and all your high points and low points. So your basic idea is that. And I've just one last thing. What you can tell, again, they're off by a phase shift. Again, I'm using some language coming up ahead. But another interesting thing about cosine is when we start the full rotation at 0, cosine usually starts at a high point. And then the sine value usually starts, right, going through the what we're going to eventually call the equilibrium. But it usually goes through the origin, if you would, right now. And I'll make more sense of that equilibrium as we move forward. But that is basically a difference that we're going to take use of. And you'll see me obviously practice it like crazy. So get used to knowing the big points. Like I shared with you, I started both graphs. Oops, where did that other graph go? I started both graphs by looking at the big values, right? What's happening at 0, what's happening at pi over 2, what's happening at pi, 3 pi over 2, and 2 pi. If I can figure out what's happening in one full rotation for those big 5, I know what the rest of the graph is doing, and then it just has to follow. Cosine starts at a high point. Sine usually starts going through its equilibrium, and I'll explain that more of that as we go along. And let's get going. Let's get cracking. Let's start doing some college algebra things with our new basic functions. Okay? And I'll see you guys in those videos coming up.